What's up, guys? I'm going to be doing example number 9 out of the PDF. And this is a basic problem on using both an electric field and magnetism and a magnetic field. So what we got here is two square, I'm not great at drawing, so two square rods here. And then a circular pole. Circular copper rod here. This is a copper rod. And the copper rod has a current flowing through it in this direction. We'll label this current I. These are at distance D apart. These are at length L. And we also have a electric field flowing downwards, which we'll label B. So what we got going on here is, because the current of the rod is flowing this way, we can look at it using the right-hand rule. So it'll be the current's flowing this way, and the electric field is flowing downwards. So the rod will move in this direction where our thumb is pointing. So we can put our velocity right here, and this is what we're trying to find. So what we'll do is take our basic equation for the force of an electric field. Force of electric field here is equal to the current times the length cross B. B is their rating of the electric field. So before we go further, let me put some values to these. D, our distance between the square rods here, is 0.12 meters. The length of the rod is 0.45 meters. The radius is 0.06 meters of this copper tube here. The mass is equal to 0.72 kilograms of the copper tube here. The electric field rating is 0.31 Teslas, or T. And let's see, the current is also 38 amps. So let's go back to this formula here. What we can go ahead and do is, we know that this is J cross K. Talked about this earlier. The I is moving in the J direction here. B, the electric field's moving in the K direction. And so we know that V will be moving in the I direction. So we can go ahead and write I down here. And then we'll just substitute some values in here. Current is 38. The length is 0.12. Actually, sorry. This is supposed to be D. 0.12. And the current is, or the electric field is 0.31 Teslas. So once you calculate that out, it comes to 1.4136 newtons in the I direction. So this is our force of the electric field. What we're going to do now is take this force, which we know to be equal to mass times acceleration, and we want to find the work that this force is doing. So we know work is equal to force times distance. Distance we'll put as x. So what we can do is take the integral here of our force FB times dx as the distance, which we then integrate into x. FB times x is equal to our work. And our distance here that the rod is traveling is 0.45 meters. So we can go ahead and write work is equal to 1.4136 times 0.45. once simplified, and once you calculate that out, you know that the work is equal to 0.63612 joules. All right, now that we have our value for work, we know that work is equal to the electrical energy of the transformed potential energy, transformed kinetic energy, transformed plus the rotational kinetic energy. This is just useful in breaking things down so we can find what exactly the velocity is inside of this work rating. So what we got here, sorry for any background noise, but nothing I can do about that. The transform formula for kinetic energy is 1/2 mv squared. So we know K to be equal to 1/2 mv squared. And then the rotational energy we know to be 1/2 the inertia theta dot squared. So we know inertia in rotational terms is equal to 1/2 mass times the radius squared. We also know theta dot to be equal to velocity over radius. So we can substitute these values in. 1/2 times 1/2 mr squared. This is theta dot squared, so this becomes v squared over r squared. These r values cancel out, so this becomes 1/4 mv squared. This is 1/2 mv squared. So then we just add these together. 3/4 mv squared is equal to our work. That way we want to solve for v here, so we bring everything else to the other side, so it becomes 4 times the work over 3 times the mass equal to velocity squared. Go ahead and get rid of that squared and put a square root over here. So then all we need to do is plug in these values. It becomes root 4 times the work, which is 0.63612 over 3 times the mass, which we know to be 0.72 kilograms. Once you calculate this out, your velocity should be equal to 1.0853 meters per second.